We're in the linked list section of Cracking the Code interview, and the question is implement an algorithm to find the nth to last element of a singly linked list. My first kind of approach was for this example, this linked list of 5 nodes. My first thought to my mind was just iterate through each one, and then so essentially you want to get the length of it. So while node's not null, you just increment this linked list length. So it would be 0, and then you look at, you just keep on increment, so it would be 1. All right, there's a node, go to next, that's 2. You go all the way till you get the length of 5. And then from there, if n, you want to get n to the last, so this is 1 to the last, 2 to the last. So you just take the length minus, so then to find, and they have another variable called toTarget, I guess you could say. toTarget, it's a bad G, would just be link list length minus n, and then you just loop through it again. So in this case it would be 3. So 1, 2, 3, and you get 11. That's one way of doing it. That's kind of like the naive, intuitive way, but that means you have to, as a runtime, have linear. You have to run through it once, and then just say it's the first to last. That means you're running through it twice. So it's 2n. So we can do a little bit better with a little trick. Without including, you don't even have to check the length of the linked list. What you have is just 2 pointer nodes. So you can say, and you want to stagger them. So you have like pointered, what did I call them? Oh yeah, and then I'm going to write this in Python code, and this is the intuitive, lines 13 through 26 this is the intuitive solution, where you just set your current node and instantiate your like list length to 0, while the current node isn't none. Then you can just add your current length or increment it, and then point the current node to next. And then your toTarget node, like I said, minus how far you want to go back. And then you just decrement toTarget until it's 0. Then with the head, while you keep going next, and you just return head at that. But whoops, we're not concerned about that. So we have, what I said with pointers, is a trail pointer and a lead pointer. So pointer lead, we can call it, and pointer trail. It's a D. I will set both these to head at the point being. Okay. But the general idea is, what you do is you have your trail here, and then you want to have your staggered, you want it to be staggered by 2, so you move it 2 up, so 1, 2. So this would be your lead. Now what you do is you move lead until it reaches null, so it would go there, and it'll go there, and that's the tail of it. But when you're doing that, you also, in lockstep, you move your trail pointer too. So you move it there, and then you move it to 11. And then whenever L terminates that while loop, then you just return the trail node. And this, you only have to loop through it once in a worst case. So, and do that, yeah, you just instantiate 2 pointers and that to the head, and then you set the head pointer, or lead pointer, I guess. While n is greater than 0, you just you make lead pointer, you move it to the right or along the linked list, and you just decrement 0 or decrement by 1 until it's greater than 0. And then once you have that, you just move the lead pointer until its next equals none, while its next one doesn't equal none, And then in lockstep, you just move both the trail and the lead pointer. And when you're all done with that, when that terminates, then you just return the trail pointer data. Um, so in this case, we have a linked list with 3, 5, 7, 2, 3, 7, 7, 7, 7. So let's see if this works here. So then it'd be Python, what I call nth to last Python. And it returns 3 because you want 3 from last place. So here's 1 from the last place, 2 from the last place, 3 from the last place, which returns 3. So let's just say we want the 4. So to return this one right here. So we expect this to return 2, which it does. So yeah, that's the, kind of a cool way to use pointers in linked lists to determine, to return something backwards. So you have just staggering pointers.